Welcome. This video will give you an overview of the latest developments in ANSA version 2025.2.0 in the area of modular run management. Designed to address the diverse challenges of contemporary simulation, the modular environment covers the needs of analysts from the composition of the simulation run up to the management of the key results, and of course for all disciplines. This release brings new developments in various areas. An alternative versioning scheme is available in ANSA. It was first introduced in version 25.0.0 for SBDRM backends, enabling the study of content-driven iterations. Now, in version 2025.2.0, this versioning method for simulation data has received various updates and is available also for file-based DMs, keeping simulation variants aligned and comparable. Let's have a look at this through an example. ANSA is connected to a file-based DM with this new DM schema that supports content-driven simulation iterations. Starting from a run configuration table, the analyst can isolate in the model browser any simulation run of interest. Assuming that all required subsystems and library files already exist in the data repository, runs can be built and saved in DM. A new grouping container, referred to as simulation iteration, is introduced in the DM schema to group simulation models that share common subsystems with identical maturity levels. Here we see all models and runs saved under simulation iteration 001. When it's time to introduce a change, the analyst can invoke the next iteration action on a simulation run listed under the simulation iteration. The definition file of the simulation iteration is loaded in the model browser, which is launched in isolate mode to display only the run that the analyst selected to perform an iteration on. All other simulation models and runs from the starting run configuration table are hidden, allowing the user to focus on the run of interest. The analyst can modify a subsystem as required. For the sake of simplicity, here we introduce a thickness change in one of the properties. The analyst can then proceed to save the simulation run in DM. The modular environment ensures that all modified and missing run contents are stored in DM. In this case, the run is saved in DM under a new simulation iteration, as the maturity of one of the contained subsystems has changed. Now, let's assume that we want to study the impact of this change in a different simulation run. The next iteration action can be invoked from the new simulation iteration. In the model browser, the isolate mode can be used in order to focus on a different simulation run this time. The simulation run contents are updated to reflect the fact that a new subsystem version is being studied. When saved in DM, this run is grouped under the same simulation iteration as the other runs that contain the same subsystem version. The added value of this working mode is that several different simulation model variants, or load cases applied on different simulation models, are all grouped together, keeping simulations aligned and comparable. Version 2025.2.0 brings new developments that facilitate the simulation model preparation. Users are now able to reuse connectors from simulation models stored in DM, which contain subsystems that are also present in the loaded simulation model. We can see this through an example in ANSA. An analyst works in ANSA, connected to a DM where several subsystems and simulation models already exist. In the assembly strategy that is utilized, intermodular connectors are directly stored in the simulation models, and there are no connecting subsystems that host them. A new simulation model needs to be built that contains some of the subsystems that are found in other simulation models. Let's assume that the analyst here needs to create a simulation model for an NVH analysis that contains the full vehicle, but without the wheels. The required subsystems are identified in the DM and loaded in ANSA. We can see that the model currently only contains connector entities that are internal to some subsystems. The analyst proceeds to create the simulation model definition and assign the desired attribute metadata. A new option is now available for the simulation model that enables the creation of connectors from simulation models that already exist in the DM. ANSA identifies all those simulation models that contain subsystems which are also present in the current model. The analyst can select the relevant simulation model and press the download button to bring the connector definitions in the current session. ANSA will fetch only those connectors whose connectivity is the same as the subsystems that exist in the new simulation model. After review of the merged connectors, the analyst can proceed to build and save in DM the new simulation model. Let's move on to a new feature in the area of simulation model comparison. Version 2025.2.0 comes with new functionality that highlights changes in the model assembly between simulation iterations. In the Compare Containers tool, differences in the connectors used in different simulation models are now listed. Let's see this through an example. ANSA is connected to a DM, where several iterations of a simulation model are stored. In the DM browser, analysts can now review changes in the model assembly. For instance, selecting iterations 1 and 3 and using the Compare Containers function, the two simulation model iterations are isolated in a new tab and compared in terms of their attributes and contents. A new category, labeled Connectors, is now available. Here, the analyst can see a comparison of the connectors that were utilized in the assembly of the two model iterations. Differences are clearly highlighted, enabling the analyst spot changes in the connector templates that were used or in the FE representation of the connectors. The final area where this version brings new developments is that of solver submission, which was first introduced in version 2025.1.0. It enables the submission of simulation runs stored in the DM either locally or on remote HPC servers. Users benefit from real-time monitoring of solver logs and key performance indicators. Version 2025.2.0 brings several improvements in terms of core functionality and user interface. Let's see this in ANSA. Starting from a simulation run stored in the DM and using the context menu option Solver Submission in the DM browser, the Solve window appears. Here, according to the file type of the selected simulation run, the Solver Submission tool opens pre-configured for the corresponding solver. When the execution is set to remote, the selected simulation runs will be exported in the export directory and the solver input files will be retrieved from that location. Once the right submission settings are filled, the job is submitted with the Start button at the top of the window. Immediately, the UI of the Solver Submission tool adjusts to display the solution progress, which is monitored live. The submitted run becomes current and is displayed with red fonts in the list of jobs on the left. The central tabs display information for the current run, such as job information and submission settings. The number and names of these tabs depend on the running solver and receive real-time updates, allowing easy monitoring of the solution progress, its convergence, or other key model indicators. In the Plots tab, a 2D plot is offered for the visualization of some key characteristics of the simulation, such as the time step, energies, and others.